Okay, so the topic for this lesson is speed and velocity. We're just going to go into some basic definitions. They sound like probably the same thing to you, but they are very slightly different. They are almost the same thing, but slightly different. So let's go into it. All right, so what is speed? It's a little bit hard to define actually, but if you take the formal physics definition, basically speed is a measure of the rate at which something's position is changing. So here's an example. You've got some runners here. You can tell they're all running. This is a 100-meter dash, or race, whatever you want to call it. So they all started the race back here. That was their starting position. The gun went off. They started running at some point later. They're now all right here. At some point further down the line, at some other later time, they will be over here somewhere. And then eventually they'll be at the finish line. So what does all this have to do with speed? Well, speed is how fast their position changes, right? So how long it takes for them to get from, say, this point to that point. All right, so if he does that quicker, obviously he's moving faster, and if he does it slower, or in longer period of time, then he's moving slower. So, okay, so that's basic idea of speed. So speed is how fast something's position is changing. Now, average speed is what we typically talk about when we're talking about speed, and how you find this out is, well, you don't really know exactly how fast something is going at any particular moment when we're working on physics problems, usually. But we can figure out how fast it was going on average over a period of time. So let's take, for example, let's suppose you're going on a road trip. All right, I know there are some roads like this in the Philippines. Nice dirt roads. Hopefully you guys don't have to drive on things like that very often in your lives, because it's kind of bumpy, not so fun. Certainly you wouldn't want to go 80 kilometers on one of those, and you certainly couldn't do it in 2 hours. But, let's just say you're going on a road trip, and you're going 80 kilometers, and it ends up taking you 2 hours when you're all done. Let's even say you stopped a couple times to use the CR, or whatever, take a little rest. But total time taken to travel 80 kilometers was 2 hours. So how do we find the speed? Well, average speed is equal to total distance traveled divided by how long it takes. So let's go ahead and do that. Total distance traveled, 80 kilometers. And how long did it take? It took 2 hours. So if we do that division, I'm sure you guys have it figured out already. It's going to be 40 kilometers per hour. And I ran out of space. So 40 kilometers per hour. Alright? So that's the basic idea of average speed. You take total distance traveled by the object, divide by how long it took, and there you got it. Average speed. Now, velocity is very similar to speed. In fact, it's almost exactly the same thing, but there's one additional feature of velocity that's not included in speed, and that's that velocity includes the direction that the object is traveling. Well, what does that mean? Well, essentially, I'll just give you a quick example down here. All right. Let's say a car drives at a steady rate of 40 kilometers per hour to the west. Well, if that's the situation, then the speed is just 40 kilometers per hour, period. 40 kilometers per hour, that's all. That's the speed, nothing else. Velocity, however, is going to be 40 kilometers per hour toward the west. You have to include the direction. So the whole thing is needed if you're going to talk about velocity. Now, that's just an example to say that velocity includes direction. Now, in our curriculum for this course, we'll pretty much only talking about motion in one dimension, which means along a straight line. So you're either going that way or you're going this way. So let's say you've got a car. I'm going to draw it really simple. Little car. Yeah, no car looks like that. That's fine. Alright, so the car is going to be traveling. Let's say it's traveling this direction. Alright, and let's say we'll just simplify things and we'll say it's going 40 kilometers per hour. Alright, so it's going 40 kilometers per hour and it's going that direction. Well, we can define this as a straight line. This straight line, we can put one end as being the plus. If it was going that way, we would call it plus, and we just call the other one minus. So this car would be traveling then 40 kilometers per hour. And actually, if you want to say the velocity, it would be minus 40 kilometers per hour. Or if we do another example that's more accurate for physics lab, alright, so we draw a straight line, we arbitrarily define one direction as plus and the other direction as minus, take our little object, and it's traveling one of these directions. This time I'll make it go the other way. Let's just say it's going 5 meters per second is the speed. Alright, so the velocity has to include the direction, so in this case we would have to say it's plus 5 meters per second. Alright, plus 5 meters per second going. That tells you that it's going toward the plus. Alright, toward the plus side. Alright, not toward the minus side. Okay, so if we were going the other direction, it would be, obviously, minus 5 meters per second. Alright, so let's just draw that in really quick so you can see it. So let's say we had a little car here. This one's going that way, 5 meters per second. Velocity is v equals negative 5 meters per second. Alright, cool. Hope that's clear. And I'll see you in class.